Good evening. My name is Nicholas.
And my name is Rushdi.
My name is Quah.
So the three of us today will be discussing about chapter 2, first order differential equations. So in this chapter, our main objective is to solve for an equation with y in terms of x or any other unknowns. So the first case of questions that we usually see are in the case where when x and y are in multiplication, we can use the separable method to solve. So the steps to solve the first order equations in when x and y are in multiplication is first, we rearrange dy dx to be on the left side on its own. Next, we factorize and simplify the right-hand side if possible. And then lastly, we separate the same variable on one side and then we integrate. So for better understanding of this, let's look at an example. So for this question here, solve x times dy dx equals to y plus 2x. So the first step, we have to rearrange dy dx to be on the left, right? So we move the x to the right-hand side by dividing the whole equation with x. So we end up with dy over dx equals to y over x plus 2y. The second step, we factorize with what we can from the right-hand side. So in this case, dy dx will be equals to y times 1 over x plus 2. So next, we move the y to the other side, to the left-hand side, and then we get the equation 1 over y dy equals to 1 over x plus 2 dx. So step 3, we integrate both sides. So first of all, we integrate both sides in respect to y and with respect to x. So we get ln x equals to ln x plus 2x plus c. So after that, we move the ln x to the left side and we get ln y minus ln x equals to 2x plus c. And then with the laws of logarithm, we can form the equation ln y over x equals to 2x plus c. And then we use anti-log, we get y over x equals to e to the power of 2x plus c. And then since e to the power of c is a constant, we can let e to the power of c to be a. So y will be equal to ax times e to the power of 2x. Yeah. My group mate Rushdi will be continuing with the second case of questions.
Thank you, Nicholas, for early explanation. Now we will move on to the next question, which is when the equation have x and y in addition or subtraction. And when equation we have a x and y in addition or subtraction, we will use the integration factor. So there are several steps for this step, for this equation, which is step number 1. We rearrange, so we will get the dy dx on the we must let the dy dx only and at the left hand side. So for the example, we have the x dy dx equal to x power of 4 minus 3y, and then we rearrange, we bring the x to the right hand side and we will get dy over dx equal to x power of 4 minus 3y over x. And step 2 is factorize or simplify right hand side if you can. So in this equation, we can see that x power of 4 and x can be simplified, which is dy over dx equal to x power of 3 minus 3 over xy. And then we will move on to step number 3. So in step number 3, if x and y in addition or subtraction, we will rearrange in the form of dy over dx plus pxy equal to qx. But first, we must know what is pxy and qx. So for qx, we will, from this equation, we know that qx is x power of 3 and pxy is 3 over xy. Now we rearrange in the form of dy over dx plus pxy over qx, and we will get the dy over dx plus 3 over xy equal to x power of 3, and we label this equation as a number 1. Next, we move on to step number 4, which is find integration factor. We will rearrange the equation in the form v power of s equal to e power of integrate px dx, and we will get the vx is e power of 3 over x dx, and we will simplify to e power of 3 ln x, and we will get the vx is x power of 3. And when we get the vx, we will move on to step number 5, which is multiply 1 with vx. So we multiply vx with the number 1 equation, which is, and we will get the x power of 3 dy over dx plus 3 over xy x power of 3 equal to x times x power of 3 times x power of 3. And we label this equation as number 2. Next, we move on to the step number 6, which is write the second equation that we label in the form of d over dx, vxy, and v equal to vxqx. And we will get the d over dx in bracket x power of 3y close bracket equal to x power of 6. And the last step is integrate both sides with respect to s. So we will get the integrate dx power of 3y equal to integrate x power of 6 ds. And when we integrate, we will get the x power of 3y equal to x power of 3 over 7 plus c. Then we will bring the x power of 3 to the right hand side, and the final answer is y equal to x power of 4 over 7 plus c over x power of 3. So that's all.
Okay, next I will be continuing on the example question of first order differential equation. So let's look at this question. So to express temperature in terms of time, first we need to look at the equation and determine which case we need to use. So in this case, we can see we don't have any time here. So we will assume that our t is in the form of 1, where t is equal to power 0. So we know that any number power 0 is equal to 1. Hence, in this case, we will use separable case because our time and temperature are in multiplication form. So first of all, we will shift our subject, which is the temperature, to the left, and we will get 1 over T minus M multiplied by delta T temperature divided by delta time equals to negative K. Then we will integrate both sides by moving delta time to the right, and we'll get the equation like this. After that, we will integrate both sides. So to integrate 1 over T minus M, we will get ln T minus M, and when we differentiate the function fx, which is T minus M, we will get 1. So when we integrate the right hand side, we will get negative K multiplied by T plus C. So according to the logarithm rule to indices, we can rearrange it into T minus M equals to e power of negative K multiplied by T plus C. So we rearrange it into T minus M equals to e power negative K multiplied T multiplied e power C according to the indices rule. Since e power C is a constant, so we will let A equals to e power C, and we will insert it into our equation, and we will get T minus M equals to e power negative K multiplied by T multiplied by A, and we will move M to the right hand side so that T as a subject at left hand side. So we will get T equals to M plus A e power negative KT, and this is our A. So now we will look at B. So we will take the information that is given from B. So first we know that the initial temperature is at 60 degrees and the time is after 5 minutes. So the time is 5 minutes. And the K constant is 0.04 while the M is 26.9. So before we proceed to find the temperature after 5 minutes, first we need to find what is A. So we knew that initial temperature, our temperature is 60 degrees. So at initial temperature, time is equal to 0. So we substitute our value into the equation, the general equation here, and where our T is 60, our M is 26.9, our K is negative, our K is 0.04, and our time is 0. And we know that any number powered by 0 equals to 1. So we will get 60 equals to 26.9 plus A, where our A is 33.1. After we get our A, we will rewrite the equation into T equals to M plus 33.1 multiplied by e power of negative KT. So we substitute our time equals to 5 to find the temperature after 5 minutes. So we will substitute the value and we will get the equation T equals to 26.9 plus 33.1 e power of negative 0.04 multiplied by 5, and we will get T equals to 26.9 plus 33.1 multiplied by 0.8187. And we will, if we press calculator, we will obtain our final temperature, which is 54. So to do a mini conclusion, so to solve first order differential equation question, first we need to identify which case we should use. So if our x and y is in multiplication form, we will use separable case where we will move y to the left hand side and our x to the right hand side. If our x and y is in addition or subtraction form, we will use integration factor. So that's all. Thank you, and I hope this video helped you to understand the first order differential equation and help you to solve the question. Thank you.
Okay, thank you.